Why does it matter that all of our devices have to actually be in sync and in time? I'll find out next right here on IT Pro TV.
You're watching IT Pro TV.
That's right, we're about to talk about time. And so here with me today, of course, is Anthony Sequeira. Too bad he's not Morris Day if he actually gets that reference. All right, so Anthony, tell us about the idea of time and why it's so important for our networks.
And, Morris Day, come on, you're in my wheelhouse. I was doing all those dances.
Oh, were you?
Yeah, I was.
Hopefully you'll have a demo of that in our show today.
Yes, I will get one of those prepared for next episode. Got a new dance. It's called the
He knows it,
yeah. Morris Day and the Time.
There you go.
Great stuff. So, the network time protocol.
Gotcha.
Yeah, you sure did. Finally got me. So network time protocol, it is super important, as Ronnie has already talked about in our little teaser for this episode. Ronnie, you asked the question, why would we care? What's the first thing that comes to your mind on why we would care about time in the network?
So I always came down to the idea of logging, right? So if I actually think that something has happened, but yet I can't prove that it actually happened at that particular point in time, then I don't know what really happened or when it happened.
You bet. Yeah. I always think security.
Right.
And I think about the logs like you do. One of the first things the computer criminal would love to do is confuse you as to when something took place. That is a classic. Also, we have to remember that many of the security mechanisms in the network today are centered around time or might have to do with time.
Like authentication.
You
stuff
got
like
it.
that. Yeah.
You got it. I mean, you can see where you could allow a group of users to only be authenticating certain times of the day. You could see where you might even have access control lists that are only allowing certain services during times of the day. So time ends up being critical. But I want to state, I completely agree with Ronnie in that by far the most important reason we care is to have accurate logging. Remember, AAA is so critical to what we do, that authentication, authorization, and accounting. And your accounting is only valuable if it's accurate, oftentimes with regards to time.
All right, so let's start off like this, okay? Just as a review, as we get started here. When we start talking about configuring time, normally when I was doing it, it was simple. They showed me how to actually configure a time on device. I would do that, then I'd move to another device. I'd configure it there too, individually, one at a time.
Yeah.
So we're talking about NTP. Why is that
we
the method
don't
that we need?
want to go hop by hop.
Okay.
And like this, it's 3 minutes after I configured that last one. It's 4 minutes since the last one. Yeah. Oh my gosh. Can you imagine manually trying to sync the time? We just don't want to do that. We're not even doing it on our Windows machines that way anymore. The Windows machine, by default, I betcha, is getting time from the internet. And that's what we're going to do. And realistically, that's what you would do in your Cisco network. Now, from a lab perspective, from an exam perspective, we're going to show you in this episode how to make your Cisco device the authoritative time source. That's not all that realistic, but you can do it. What we typically do is have one of the Cisco or multiple Cisco devices get the actual time from an atomic clock source out there on the internet. They get that securely, and then they feed it into the rest of the infrastructure. But we'll have some real fun in this episode. Right. We'll make one of our routers the authoritative time source, and then we'll get that time from the other devices. So Ronnie, let's jump into our topology. What I cooked up is just, I didn't cook this up today. We recognize this. We were playing with some BGP right here. And we'll just go in and use this topology because it's handy to us. And I want to emphasize again, for those of you watching, you have access most likely to your hands-on labs portion of your subscription. And so what you want to do is get in there and practice this. And
I couldn't hear what you said.
yeah, thanks, Siri. That's okay. That's because I'm not talking to you. That's some funny stuff. That's going to be one of my favorite moments of these episodes so far. So here we go. We are going to we're going to go to the R1 device, and let's have this device be the authoritative time source. We'll pretend that we're super happy with its ability to keep time. By the way, don't we do a show clock to see what is going on from a time perspective? And of course, we could manipulate that local clock to be more accurate, to reflect the time zone that we want and all that good stuff. All right, here we go. The commands begin so simple, NTP, just as you might suspect. Now notice you've got a ton of options. Let me do that one more time. I think I stopped it before it was even done. Well, there you go. There is a ton of options here. For instance, you can do NTP in several different modes. Like there's an NTP peer command where you can have devices have the ability to update each other. But what we're going to do is a classic config, and I'm even going to put in the show notes for you where you can download a security config of what we're going to do. So I'm going to show you the basics, and then I'm going to give you some show note downloads that will have you even secure what we're doing. But the basics is to say, I am the NTP master of the network. This is where we are saying that this device possesses the absolute correct time. We're making this device the source of correct time. Now, a confusing term is in here, and that is stratum.
Right.
What a great word. What that is it's you telling this time source, it's basically a measure of accuracy. You see how this works is you could say, well, I'm actually getting my time another way, so I'm like 4 basic hops away from the true source of time. And that's how you can approach the stratum. So the lower number is better, so you'll see many classic configurations this way with Cisco, where you're saying, this is the time, and I know it, and there's no distance between me and the correct time. So a very interesting value, the stratum.
So this means, at least for our configuration, what we're doing is that R1 is going to be that authoritative time source for R2 and then the rest.
For anybody else, that's right.
Okay.
And we're using that lowest possible stratum to say that we have the best possible awareness of the correct time.
Right.
It's really a unique setting. So that's it. NTP Master 1. Now the confusing part of this configuration. This is so tough to get your head around oftentimes. What we're going to do is we're going to go over to a device that's going to receive the correct time from that master, and we're going to use a command that confuses everybody, NTP server. We immediately think when we first see this, oh, this is the machine that's giving the correct time, but it's actually the opposite of that. This is how we configure the client system that's going to be receiving the time.
Right.
And we need to give the IP address of that NTP master device. So 192.168.0.1. And by the way, there would be options there. And one of the options that we get there is the security options. Notice you can set a peer authentication key. And again, I'll give you the secured way to do this in the show resources. So there we go. NTP server 192.168.0.1. We would want to do a ping to make sure that there's reachability, because if there's not reachability, you're not going to be happy with the network time protocol. So Ronnie, the challenge for you in the CCIE lab exam, or even, I'm not kidding, this could be a challenge in the Encore exam. If they present you with a simulation, they'll build in the time that it takes to verify this. It's ironic, isn't it?
Yeah.
You would think that, okay, that configuration was so simple and so critical for the operation of our network that it must work right away, like we're used to things working. You think about even a BGP peering. BGP is not known for its conversion speed, but even that, it's a few seconds and boom, you got your peering. This can take what we would say a long time to peer. And look at this. These R1 and R2 devices, they are directly connected with each other. So imagine when you're configuring this in like a lab exam and you've got 30 devices in there and there are many hops from each other. This can take a long time to sync. I've been killing time. Let's see if it's synced. So the big command that you want to do on this one, the primary command, is show NTP associations. That's that first command that I reach for from a verification perspective. And it says that it's configured on this device for 192.168.0.1. The reference clock is in it. You can see we are not synced. And another command that you can do is show NTP. It is our status command, show NTP status. And notice that we are unsynchronized, that we don't have a reference clock. And this is just the frustration here. If you're in production, no problem. You set up your NTP and go to lunch. If you're in the CCIE lab exam, no problem. Go work on other stuff. Do not just sit here. That's an easy way to fail and go, I'm just going to sit here and wait for this to sync. Hopefully it syncs at some point. Go do other stuff. Please don't waste time sitting here staring at this. This can take a while to sync. So let's hope it syncs for us on screen. But isn't that amazing? These things are back to back, and there's a process going on here. They're doing all kinds of fancy polling of each other, and it just takes a while. And there's nothing I've ever seen, by the way, that we could do to speed it up, other than one thing. I'm so glad I thought of this to mention. If your clocks aren't close in sync already, you're in really big trouble. It's going to take hours for them to sync.
Now, we do have a question actually from our studio chat, right?
Awesome.
So someone asked, especially since the way that we set up R1 as being our source, he says, can that clock, like PCs, also sometimes drift? And should we be periodically updating that one from a known source?
Yes. Great point. So if you are going to be using one of your local network devices as the authoritative time source, you will want to make sure, and such a great question. I love the studio audience. One of the things that you can do is use tools, and this is one of the reasons why there's tools like Ansible out there. One of the most common uses of a tool like Ansible is to go into your network devices and update their time. Make sure that those time sources haven't had substantial drift. So that is a great point. And that's something we love to automate. And you set that up to be occurring on some kind of interval that you're comfortable with. And again, accurate time for one organization is going to be different from accurate time for another organization. So you could foresee like some type of company being like, we're okay with 5 minutes adrift, no big deal. But you could see some other company being like, 5 minutes adrift. Our time needs to be accurate within 30 seconds, So
now let me ask another question, because I've seen this as well. When you set up devices, let's say for a customer of yours, and we need to do the NTP, do you set them up using the UTC time, like what I see recommended, or do you actually just do the local time?
Yeah, UTC is how I've seen it absolutely most. And it's really funny too, when I'm talking to my international folks, they're always like, whoa. What's the UTC translation? So we should really get used to that. It wasn't a big deal for me, actually. I had a little head start in this because I'm a pilot.
Right.
And, with the Federal Aviation Administration and everything, they just had me thinking in Zulu time, so I was kind of used to that concept. But it is something valuable to get used to. Another one that's I had to get used to is military time, is the 24-hour time. That's another good one to get used to. Well, Ronnie, we can wrap it up. You know what we'll do? We'll leave this running, and we will make sure that we had synchronization, and I'm sure we will, but it just takes, ironically enough, time.
All right, Anthony. Well, thank you for showing us at least the setup of this. And you notice that there's not really a lot of configuration, but getting those commands on the right devices is going to be key in the synchronization that happens. We also had a little bit of time to describe NTP itself, and we had a question or two that really did help us to formulate what time should we set, as well as can we kind of counteract against the idea of drift here too. So that is a great place for us to end this episode then. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.